Hello everyone and welcome to Mr. T's Maths. In this video we will be factorizing quadratic expressions with two terms. Okay, so expressions of the form ax squared plus bx. Before I move on, I'd like to remind you that factorizing is the opposite of expanding, right? So when we have an expression such as x times x plus 5 and we expand that, so we multiply out the bracket, we end up with x squared plus 5x. Okay, so this process here that takes us from a product to an addition of two terms is called expanding. Okay, well, the process that takes us back from having a sum here of two terms to having a product is called factorizing. Okay, so factorizing. So in our minds we should think that basically we are aiming to get an expression from this form to that form as a common factor, the highest common factor outside the bracket. Okay, that's what we are aiming for. So the type of expressions we are going to see are of this form: x squared plus ax or x squared minus ax, and these are the two types of answers we will be looking at. Then we have the special case called difference of two squares, which is this. Difference of two squares, and that's basically when you see here the difference. It's exactly what the name says. It's the difference, so subtraction of two perfect squares. Well, there's no point me telling you now. We will look at some examples afterwards. And then you have to be very, very careful not to confuse this difference of two squares with cases such as this one, where there are two squares but they are added together. That cannot be factorized. And last is the fact that you can always check your answer by expanding back the bracket. So if you expand this, you should end up with the original expression. If you expand that, you should end up with this, and if you expand two brackets like that, you should end up with this answer. Yeah, okay, let's move on and try it out. So x squared minus 12x, we have to look at these two terms and find the highest common factor. That's what we are looking for. What's the highest common factor between x squared and 12x? Well, the highest common factor in this case is x, and that's what will end up outside the bracket. Yeah, because remember, factorizing is the opposite of expanding. So we have to take this expression, we want to rewrite this expression as a product, basically x times something. Well, what's this something? X times what gives me x squared? That's x. And then x times what gives us this 12x? That's just 12. Okay, and that's basically it. Okay, another way of looking at it is using division, if you like. So I'm just going to show it to you here. So you know that x is outside, the term outside the bracket. Now what you need to do is basically take that first term, x squared, divided by this term outside, x. What's the answer? X. So that's what goes here as your first term inside the bracket. Then we take the second term, 12x, and we divide it by the highest common factor, which is x. What's the answer? 12. So that's why you have a 12 there. And then this is a minus, so you will end up with a minus here. Okay, so there are, if you want to call it like that, two cases, two different approaches. Yeah. All right. This second example, I want us to look at it kind of just to do it backwards. Let's see what's the answer what answer do we get when we expand x minus 3 times x plus 3? So I'm just going to copy this again. Remember that in a previous video we looked at expanding double brackets, and we learned this method FOIL. F stands for first terms multiplied together, that gives us second x squared. Then outside terms, O stands for outside, x times 3 is plus 3x. Then inside terms, minus 3 times x is minus 3x, okay? And L for last, x minus 3 times 3, which is positive 9. Okay, what do you notice? You probably have already noticed that these two terms here cancel out. 3 minus 3, 3x minus 3x is 0. So our answer is x squared, and that's, sorry, made a mistake there. That is a minus there. Minus 3 times positive 3 is minus 9. So x squared minus 9. Okay, and this is the famous case. We can distinguish this. This is the difference of two squares. Okay, yeah, so whenever we have to factorize something like that, basically factorizing this expression takes us back to these two brackets. Okay, great. So I have prepared some examples for you to do, so please pause the video and try them yourselves, and then just check your answers against mine. Yeah, so the first one, the highest common factor here is x. That's what goes outside the bracket, so we end up with x minus 3. Let me just get rid of that. X minus 3. Okay, alright, second example. Again, highest common factor is x. Now x squared divided by x is x. 2x divided by x is 2. Alright, question 3. X times the common factor is again x. X times what gives us x squared? Well, that's simply x. X times what gives us 31? It's 31x. That's just 31. Okay, question 4, the answer is x times x plus 42. Okay, and then we have our lovely special cases. You probably have recognized already that these are perfect squares. Why are they perfect squares? Well, 16 is nothing less but 4 squared. So this is a case of two brackets. This, when we factorize this, we get two brackets, and it's x minus 4, x plus 4. If you don't believe me, just expand this and see what you get. Okay, what do you get? You should get the same thing as there, as we started with. So question 6, x squared minus 49. 49 is 7 squared, so we end up with x minus 7 times x plus 7, and that's it. Okay, and I have a set of, let's say, slightly more challenging. We have a couple more examples of difference of two squares. Okay, again, please do pause the video and try these yourselves. Yeah, so the answer here is x times x minus 312, x times x plus 51. Here, yes, as you probably have thought of, 64 is 8 squared, so x minus 8 times x plus 8. Okay, and 121, if you know your times tables, which I'm pretty sure you do, it's 11 squared, so that's x minus 11, x plus 11. Alright, 225 is 15 squared, so x minus 15 times x plus 15, and 4x squared minus 16, the solution is, well, this here is a square number because that's 2x everything squared, if you think about it. Yeah, it's 2x times 2x, yeah, which is 2x times 2x, so it is a square number. So here we should end up with two brackets, 2x minus plus, and then what gives us that 16 is 4 times 4. All right, I hope you are happy and you've had all of this correct. You're happy with your answers. All right, and yeah, please do watch these videos with a piece of paper next to you or your notebook, and try to go through all the examples on your own, because you can't learn maths just by watching. You actually have to practice it. Yeah. Anyway, here we are at the end of this video. I hope you feel more confident at factorizing quadratic expressions with two terms, and don't forget to watch the next video, which will be factorizing quadratic expressions with three terms, yeah, in the form ax squared plus bx plus c. Okay, take care, bye bye.